Dear learners, welcome back to my YouTube channel. In this video, we'll be seeing what is Poisson distribution. In the last video, we have seen that there are three different types of theoretical distribution, wherein the first one we have seen is binomial. We have completed. In the last video, I have told you what is binomial and the computations in respect of binomial distribution. In the same way, we are going to see the Poisson distribution. There are similarities in binomial as well as Poisson, since this binomial and Poisson distribution refers to discrete probability distribution, and it is widely used in case of statistical work. And Poisson distribution is named after French mathematician Simon Denis Poisson. Hence this distribution is named as Poisson distribution. Poisson distribution is basically expected in cases where the chances of any individual event being success is very small. For example, the value of P is your success, as I've told you, P is success and Q is failure. And the chances of the event being success is very small. The chances of event being success is very small, and Q is almost very near to 1, which means P is near to 0. And this distribution is particularly used in order to describe the rare events. Rare events means what? The occurrence of such event is very rare, like number of accidents, like number of printing mistakes in a book, etc. And this is known as law of improbable events. Let us see how this Poisson distribution is being defined, how it is being computed. As we have seen in case of binomial distribution, the formula was PR is equal to NCR Qn minus R P to the power R. This was the formula which we have seen in case of binomial distribution. It means what? In order to get any term, this we can solve and we can find out. Likewise, in case of binomial also, the concept is the same. We are using R. You can see we are using R. The same meaning is number of success, right? Let us see what is the formula in case of Poisson distribution. PR is equal to e to the power minus m into m to the power r divided by r exponential. This is the formula. And how you have to compute? Is the value is a mathematical constant which is being fixed at value 2.7183. This is the value, fixed value for E. It is a base of natural logarithms and a mathematical constant, and it is fixed at value 2.7183. No confusion, this is the value which we are going to take at every place wherever this E comes. And what does this M refers to? M refers to mean. M refers to mean. The same formula we can use as we have seen in case of constants of binomial distribution. First one, mean of binomial distribution. Likewise, mean of Poisson distribution also NP. Or otherwise, this one. This one means what? Why I have written this? In order to, in case if value of n and p is not given, we can easily compute the value of mean by using the formula which you would have studied in case of measures of central tendency. There are very different methods. You would have used different methods, and accordingly, since this is a discrete probability discrete series, the formula in case of discrete series, there are two methods of formula in order to find out the mean. First one is your direct method. Second one is your shortcut method. One more formula also you can use, that is known as step deviation method, which is an actual method of continuous series. But there are instances where we can use uh, this is the formula. And I've already told you the values. This all already have explained. This is in case of R, as I've told you, it refers to number of success. It refers to number of success. Like we have studied in case of a binomial, the different terms. Likewise, we too have different terms here. These are the different terms we are having in case of binomial Poisson distribution, e to the power minus m. For example, if you're finding out the value for zero success, finding out the value of zero success, it is being expanded like this. It is being written like this. Success in terms of expanded is expanded like this. In case of zero success, the value is e to the power m into 1, e to the power minus m. Likewise, in case of one success, the value is e to the power minus m to the power r is what? R is 1. So, r is 1 divided by r exponential means what? It is also 1. So, no need to write this. So, e minus m. Likewise, for 2, as I have told you, the formula is, what is the formula? And according to the formula also you can make note of it. For example, for 2, for example, P2, R is 2, e to the power minus m, m to the power 2 divided by 2 exponential. You can see the formula. Likewise, if it is 3, 3 exponential, 4, 4 exponential, and the value of m will, the power of m will be the r. So accordingly, it is number of success which you are finding out, right? And m refers to what? Refers to the mean of the Poisson distribution, which may be NP, or the method, or the, or you can compute using the observed frequency, you can compute the value of mean. Let us see what are the constants of Poisson distribution. As we have seen in case of binomial distribution, the same constant we are going to see in case of Poisson distribution also. In this case, as I have already told you, that the value of P is very small and the value of Q is almost equal to 1, which means that the chances of any event being success is very small. It is known as P, and failure is more, it is known as Q. Let us see. First one, mean of the Poisson distribution. Mean of the Poisson distribution is m, which is equal to np, or arithmetic mean, which we have studied. In case if np is not given, we have to find out the arithmetic mean using the long cut method, as we have seen in measures of central tendency. Next one is standard deviation. The formula of standard deviation is very simple, root over m. First moment is 0. Second moment or otherwise variance is also the value of m. Third moment and second moment value is m. Fourth moment, the value is 3m plus 3m square. This one. And measure of skewness is 1 by m. Measure of kurtosis is 3 plus 1 by m. This is the measure of kurtosis. 1 by em is the measure of skewness. Very simple formula, and you can see that in order to find out all the constant, you only need the value of m. It is not, in case of binomial, we need the value of n, we need the value of p, we need the value of q, so many values we needed. But in here, you need only the value of m in order to find all the constants of the Poisson distribution. Let us see one illustration. The mean of the Poisson distribution is 2.25. The mean of the Poisson distribution, this is your m, and you have to find out the other constants of the distribution. It's very simple. Mean of the m is given, and you can apply whatever the formula we have seen, that formula you can apply, and you can find out the various values of various constants of the Poisson distribution. When the mean of the Poisson distribution is given, it is very easy, very simple to find out the different all the constants of the Poisson distribution. Namely, mean, standard deviation, first moment, second moment, third moment, fourth moment, skewness, as well as kurtosis. Yes, see the second sum here. The second sum is that on an average, one house in 1,000. It means what? Average what happens? One house in 1,000 is getting a fire during a year. This is the probability of success, that one house in 1,000 is getting fire during a year. For example, if there are 2,000 houses, how many houses will get fire? If in, it means what? In case if in 1,000, among 1,000 only one house is getting fired, in 2,000 two houses, that 2 is what? 2 is your mean. So let us see the formula for finding out the mean, right? Mean is probability is your probability of success. P is your 1 by 1,000, N is your 2,000, right? And R, what is the probability that exactly 5 houses will have fire? You have to find out R. You have to find out PR. That is e to the power minus m. M to the power R is how much? R is 5. 5 divided by 5 exponential. This is what you have to find out. Because यहाँ पे आपको क्या चाहिए? What you wanted is, you wanted R equals 5, which is success, which is your success. So among 2,000 houses, what is the probability of getting 5 houses fired? So you have to solve this formula. How to solve this formula? You can see how you have solved this formula. E to the power minus m, m to the power r divided by r exponential. This is the value which I have already told you. It is approximated by 2.7183. M is what? M is 2, minus you have to write, and 2 multiplied by m to the power r. M is how much? 2, and r is how much? 5 houses, divided by 5 exponential. Exponential refers to what? You have to multiply backwards. 5 into 4 into 3 into 2 into 1. If it is 6 exponential, 6 into 5 into 4 into 3 into 1. If 5 exponential, you have to write 5 into 4 into 3 into 2 into 1. If it is 3 exponential, 3 into 2 into 1. Likewise, it will be right. You will be writing. Right. So in this case, the remaining figures are very easy to compute. No confusion. The only thing is in case of computation of the power with minus sign. You can see 2.7183 to the power minus 2. Once you are solving this, the answer for the other you can easily find out. As you have already seen the log and antilog, finding out log as well as antilog in the geometric while studying geometric mean method. You have already seen that. Let us see here that how we can find out this. It is difficult in order to compute the value in case if it is having a minus sign. So in order to find out the value of this constant 2.7183 to the power minus 2, in order to solve this, we can use the log table. Log and anti-log table we can use in order to find out. How we have to find out? You can see what you have to, in order to, just I am telling you about the about this one. I am going to tell 2.7183 to the power minus 2. How you have to solve this? First write down REC means reciprocal. What the result you are going to get? I am going to write the formula inside this. What the result you are going to get? That value. For example, if you are getting 2, value 2, it need to be reciprocated. It is what? 2 by 1. In case if you are reciprocating, it will be 1 by 2. That answer you have to find out. Okay, that is the meaning of reciprocate. What you have to write down? You have to write down antilog. This value 2 you have to write down here. Antilog 2 multiplied by log of 2.7183. Right, this much. Remaining figure is clear to you. Remaining you can easily find out. You have to 5 times of 2 and you have to multiply this. Not an issue. So how you have to find out this? You can see I have told you about this one. This figure I have told you about this figure. Antilog 2 into, you have to find out the log 2.7183. In order to find out the log, only 4 digit is enough. As I have already told, go to the log table. In the log table, you can go for, forget about this point. Point ke bare mein bhul jaye, forget about this point. Take the value 27. 2 digit you have to take. Take the value 27. In 27, you just go for the value 1. Okay, 27 you are going to see in what? See in row. You are going to see like this. See here you are going to see 1. Value 1. For example, this is 27. What the value here written, that you have to find out. One more column will be given known as mean difference. Mean difference, in that you have to go for seeing 8. Likewise 1, 2, 3, 4, likewise 8 number will be there. In that 8 number, what value is given, that need to be added with this value. This value. इसके साथ आपको क्या करना है? That value need to be added and that value need to be written. So after writing that value only, you are getting 0.4343. Right? Then after 0.4343, what you have to do? You have to multiply 0.4343 into 2. Once you are multiplying this, you will be getting this result. Once you are getting this result, you can find out the antilog. Right? You have to find out the antilog. So this is the way how you can find out the value of e to the power minus m using the log and antilog. So what you have to do is you have to reciprocate this. After finding out the antilog, you will be getting this value. Once this value you are finding out, the remaining remaining multiplications you can do. This is with this and you will be getting this value, which means that 0.03, which means 3.6% chances is there that 5 houses will get fire out of 2000 houses. The next one is 10% of the tools produced in a certain manufacturing process turns out to be defective. So defective portion is your success. P is given 10%, 10% which is equal to 0.1, 0.10. And if P is known, you can easily find out Q with the help of simple formula 1 minus 0.1 10 is equal to 0.90. Right, this is the formula which you can find out. So you know the value of p and you know the value of q. Next, what you have to do, find the probability that in a sample of 10 units you are having a sample of 10 numbers. Matlab n is your 10 which is chosen at random. You have to find out that exactly 2 houses are getting fire. So therefore what is r is equal to 2. Okay, m to the power r will be 2. Okay, 2 houses is getting fired. So first what you have to do is you have to solve the probability by using two distributions known as binomial distribution as well as Poisson distribution. We have already seen binomial distribution. We did sums also. You can see how to do the binomial distribution. In case of binomial distribution, you have to expand this q plus p to the power n to the power 10. N is your 10. You just expand it and you have to see that the probability or that exactly 2. Exactly 2 means what? You have to choose that term whose power of p is 2. Whose power of p is 2. If power of p is 2 means the power of q will be 8. Always remember that the power of p and the power of q when added together will be equal to n. Right? Okay. So this is how the expansion is being done. You have seen that the power of q is 8 and power of p is 8. Sorry, p is 2 and the power of q is 8. Likewise you can see here, and you have to solve this method we have already seen. And the second method using it is what? Poisson distribution. Using Poisson distribution you have to solve. Using Poisson distribution you have to solve. In case of using Poisson distribution, in order to solve the Poisson distribution you should know the value of m, and the formula of m is np. We have n is 10, we have p is 0.1. 10% defective, so 0.1 and 10 both we are having, so we can use this formula and we can go ahead. Right, and what is r is your 2. Just use this formula here. 2.7183. M is what? M is 1. 2.7183. M is 1. So by using the same formula which we have seen earlier, using anti-log and anti-log, just you have to write reciprocate within bracket anti-log of 2.7183. First you have to write down the power value down, then have to multiply 2.7183. Right, you have to take the antilog of this, and this need to be reciprocated. This value need to be reciprocated, not 1. Mistakenly I have written the bracket here. You have to take the reciprocation of this value, antilog 1 log 2.73. Once this is solved, you take the reciprocation, then reciprocate. After reciprocate, you multiply with 1, and the other values you can multiply and you can get your answer. Since it is 1, it makes no difference, you can see. So therefore the probability of getting two tools defective are 0.1839. 0.1839. In case of using binomial distribution, you are getting 0.1937. Different methods you are using, accordingly you will be getting different answers. This is next one. We are going to see fitting of Poisson distribution. As we have seen in case of fitting of binomial distribution, we does have fitting of Poisson distribution, and Poisson distribution is fitted in order to find out the expected frequency. I have told you what is expected frequency, what is observed frequency. Expected frequency is computed on the basis of some theoretical considerations or some past experiences we are computing. And in order to compute the expected frequency, the same formula which we have seen in binomial, in case of binomial we have multiplied with n. Likewise here also we have to multiply with n. But in case of Poisson distribution, the process is more simple because no need to multiply n every time. Once it is multiplied, we can take that value with the other, and ultimately we can multiply and we can go ahead. This is the formula how we can compute. For example, for our success, what you have to do? N you have to multiply with NPO. This is your NPO. Second time, what you are going to do? You are going to, for zero event, for first event. Right, for first event what you are going to do? Already you have got the probability. Already you have found the probability NPO with the value of this is n e to the power minus m. Better you can find out the value of this and then multiply with n, and automatically every time there is no need to show this value e to the power minus f. Since it is there in all the values, you can this value will get multiplied in the first value itself, and this you can take over. You see, in order to find out np1 second value, what you are doing, np0 first value you are taking into 1, then divide, then iske niche mein kya hai, 1 hai. Likewise in the second probability it is m by 2, in the third m by 3, fourth m by 4. Just you are multiplying the previous values, and every time what you are doing is you are dividing the mean value with one more number. Like if it is m1 earlier, first it was m by 0, then m by 1, m by 2, m by 3, m by 4, all values aega, it will be m by 5, m by 6, likewise it will go on. Let us see an illustration. The following mistakes per page were observed. The meaning of this is what? This is observed. It means this is the observed frequency given or actual frequency given. Okay. We are going to find out what frequency, expected frequency. So for 0, the number of mistakes, the number of times mistake occurred, number of mistakes per page. There is in 211 pages there is no mistake. 90 pages there is one mistake. 19 pages there is two mistake. In there is number of mistakes per page. There is 4 mistakes in no pages, right? So likewise you can see that this is the meaning how you can derive that 3 number of mistakes are there in right, 2 mistakes occurred in 19 pages, 3 mistakes occurred per page, 5 in 5 pages, 5 times it has occurred, 4 mistakes occurred in nil. So therefore this is what known as how you are going to study this observed frequency, and this is the observed frequency which is being found. Let us see how we are going to fit the Poisson distribution. Fitting of Poisson distribution. Let the number of mistakes per page. For example, this is nothing but this is your variable x and this is your frequency. This I have shown here with the help of this. And how you are going to do? You just x you find out. You can compute the value of mean using a very simple formula. This is the direct method. I have used it in order to find out direct method. The formula is summation of fx divided by n. Very simple. Since the values are very less, we can use this formula, right? You have to find out the value of x, and this is the total of n, and you have to multiply these two in order to find out fx, and find the total of this summation of fx you will be getting. And after computing the value of mean, the value of mean is what? 0.44, and this value is your m, right? You have got the value of m, mean is equal to 0.44, and with the help of the formula which I have told you earlier, e to the power minus m, you have to find out the value of 2.7183 to the power minus 0.44. So this value you can get, this is the 0.44, e to the power minus 0.44, right? The same we can see find out with the help of a table which I have shown here. This is the table which I have shown here. Once you are computing, you can check your answer also. 0.44. Where is this 0.44? This is 0.44. You see 0.644. Right? We have seen 0. For e to the power minus 2. You see single 0.135 we have already seen. So on the basis of this table also we can find out the value. So this is how you can compute the value of you can compute the value of, you see this is your 6.44. Once you have got the value of 6.44, you can compute the remaining values on the basis of the formula of expected frequency. You see, so simple, computing the value of expected frequency NPO n e to the power minus f. N is your 325, you have multiplied this 209.3. Likewise into m 0.44, then this value you have taken 0.44 divided by 2, then 0.44 divided by 3, then this value you have taken here 0.44 divided by 4. This is how you can compute the value of expected frequency under Poisson distribution. You can see the value is tabulated like this, and the total is almost equal to 325. Similar type of sum I have given. You can just try it out. That here the following table gives the number of days in a 50-day period. 50-day period during which automobile accidents occur in a certain part of city. This also accident, you can just, that was the number of printing mistake, it is in respect of number of accidents. So you can solve this sum and you can find out your answer, and your answer should be this. Just try this sum, try solving this sum and find out the answer. Next one is again a simple sum. Here the value of e to the power minus 2 is already given, so no need to use that log, antilog use. There is that is not required. Since the value is given, e to the power minus 2 is given, it is also very clear that m is, the value of m is what, m is 2, because we know that e to the power minus m, it is already given, e to the power minus 2, which means the value of m is 2. Suppose that a manufacturer predicts 2 defect per unit of product, 2 defect. This 2 is what? 2 is your m. This 2 is your m. What you have to find out? You have to calculate the probability of finding a product without any defect. Without any defect matlab P0 you have to find out, P3 you have to find out, and P4 you have to find out with the help of that formula. For finding out P0, what will be the value? Value is e to the power minus m, that's all. E to the power minus m, you see, e to the power minus m, the value is this one. You will be getting. Likewise, for finding out the value of P, for 3 defectives, what is the formula? E to the power minus m to the power r divided by r exponential. What you are going to use? P to the power, here you are going to write 3, here you are going to write 3, right? And you can solve the sum. You will be getting the answer. You can see this is your answer, 0.18. Likewise, you can do for 4 defects also. Yeah, this is very important sum. You can see that in a certain factory manufacturing razor blades, there is a small chance of 150 for 1 by 50 for any blade to be defective. This is the chances of success given, that is P. P is 1 by 50. You can see, and the blades are placed in packet, each containing 10 blades. In one packet there are 10 blades, right? This 10 is what? This 10 is your n. Okay, this is also being written, n is equal to 10. Using the Poisson distribution, calculate approximate number of packets containing not more than 2 defective. Not more than 2 defective means what? You have to find out how many packets are there which does not have more than 2 defectives. Like, not more than 2 defective means you should see that it is having 0 defective, 1 defective or 2 defective, but not more than that. So you, from 10,000, what you have to do is this, from 10,000 packets, this is your capital N. From 10,000 packet, you have to subtract P0, right? P0 means what? You have to multiply with N. You have to find out the success for P0, 10,000 ke sath you have to multiply, right? And you have to find out the NP1, you have to find out NP2. This you have to multiply. Sorry, this you have to find out, you have to add together, and you have to minus with, subtract with the 10,000 packets. You are having 10,000 packet, and in each packet there are 10 blades. So that 10 blade is what? 10 blade is your small n, right? The first one, just find out 0 defect, is because you need to have the value of e to the power minus m, and the value is 0.8187. So in order to find out the probability for 0 defective, you have 8187 value you are having, multiplied with 10,000. It means what? Out of 10,000 packets, 8,187 does not have any defects. It means what? All the blade in 8,187 packets, the blades are, there is no defective blades. 8,187 packets, there is no defective blades. Second one is, you have to find out with one defective, right? What you have to do? You have to multiply NPO. You can compute in continuation, you can compute 8,187 into m, m means what? M by 1 is there, you have getting this. It means what? One defective you can find in this number of packets, 1637 packets, you can find one defective approximately. Okay, in P2 163.74, you can find out approximately 164 packets may be having 2 defectives. So what you have to do, you have to add 8187 plus 1637.4 plus 600 and not 6 163, sorry. You have to add these three numbers. After adding these three numbers, you have to deduct it from 10,000 and the value which you are getting, like you're getting what value, you can see you are getting 11.86. It means what? Approximately 12 number of packets may be containing not more than 2 defective blades in a total of 10,000. This is a very important sum. You can go through this all the sums, you can practice the sums, you can try to understand, see the complete video, then only you will be understanding, and after seeing or simultaneously you can practice it so that you can understand better and keep learning. Thank you.